For any triangle ABC, if A, B, and C are in arithmetic progression, show that cotangent of A over 2, cotangent of B over 2, and cotangent of C over 2 are also in arithmetic progression. Okay, let us begin. So first, we'll try to understand the terminologies and also the formula that we'll be using. So here, let's say we have a triangle ABC. Now for this particular triangle, the sides opposite to angle A will be represented by A in lowercase. Sides opposite to angle B will be in B in lowercase, and the side opposite to angle C will be denoted by the letter C in lowercase. Now here, if we take the sum of the sides A plus B plus C, this is going to give us the perimeter of the triangle. And if we divide it by 2, then this expression is going to represent the semi-perimeter of a triangle, which is denoted by the letter S in lowercase. And also, we have a formula for cotangent of A over 2, that is the half angle formula. Yeah. So here, we'll be using the half angle formula to start our problem. So here, we are going to presuppose that the three terms, cotangent of A over 2, cotangent of B over 2, and cotangent of C over 2 are already in arithmetic progression. Now, if they are terms of an arithmetic progression or terms of an arithmetic sequence, then we can immediately say that cotangent of B over 2 minus cotangent of A over 2. That means we take the second term and from it subtract the first term. This difference is exactly going to be the same as take the third term, cotangent of C over 2, and from it subtract the second term, that means cotangent of B over 2. They have a common difference. Or in other words, we have 2 times the middle term, cotangent of B over 2. This is going to be equals to the sum of the first term and the third term, and cotangent of C over 2. Since we have the formula for each of the cotangent function, so let's use them. Now on the left hand side, we have 2 times cotangent of B over 2. So we have 2 times the square root of S multiplied to S minus B divided by S minus C times S minus A. This is going to be equals to the square root of S multiplied to S minus A divided by square S minus B times S minus C. Added to cotangent of C over 2, so that's square root of S multiplied to S minus C whole divided by S minus A times S minus B. Right. Now here, what we can do, from both sides we have S in the numerator. Actually what we can do, we can factor out square root of S from both of the two sides. This is going to simplify our problem. So we have 2 times the square root of S minus B divided by S minus C times S minus A. This will be equals to the square root of S minus A divided by S minus B times S minus C, added to the square root of S minus C whole divided by S minus A times S minus B. Fine. Now we will combine the two terms on the right hand side. So we have 2 times the square root of S minus B divided by S minus C times S minus A. This is going to be equals to, so we will combine the two terms on the right hand side. So our common denominator is going to be the square root of S minus A times S minus B times S minus C. And in the numerator, we have S minus A added to S minus C. Right. So we now have square root 2 times the square root of S minus B divided by square root of S minus C multiplied to S minus A. This is going to be equals to 2 times S minus A minus C divided by, so here what we can do, we can rewrite the denominator as square root of S minus B multiplied to the square root of S minus C times S minus A. We have done this so that we can easily factor out the common denominator from both sides. This is going to be equals to 2 times square root of S minus B. This is equals to, now what is 2s? 2s is simply A plus B plus C. That means 2 times the semi-perimeter gives us the perimeter A plus B plus C minus A minus C whole divided by square root of S minus B. So here we have A, negative A, C and negative C cancelling out, and this is now going to give us, so we're going to cross multiply 2 times square root of S minus B multiplied with square root of S minus B. That's simply s minus b. We have 2 times s minus b. That is going to be equals to b. Let's further simplify. So we have 2s minus 2b equals to b, which is going to give us 2s equals to 3b. Now 2s is given by a plus b plus c. That's equals to 3b, which is going to be equals to a plus c equals to 2b, or we can say b minus a equals to c minus b, and this tells us that a, b, c are in arithmetic progression. So we started out by considering that the three half angles, cotangent of a over 2, cotangent of b over 2, and cotangent of c over 2 are in arithmetic progression, and we were able to show that ABC are in arithmetic progression. However, in this problem, we see that it is given already that ABC are in AP, and we had to show that these three terms are in arithmetic progression as well. That means, given the premise that ABC are in AP, we have to conclude that these three terms are in arithmetic progression as well. However, we took an alternative approach. So we presuppose that the conclusion is itself true. If the conclusion is true, that means the premise must be true as well. This is what we did. So when we started out by considering cotangent of a over 2, cotangent of b over 2, and cotangent of c over 2, the conclusion to be true, we found out the premise was also true. That means ABC are also going to be in arithmetic progression.